Good morning and good afternoon to everybody, and thank you for joining the IIoT World Energy Day 2023 edition. It's the pace of change in the energy industry today and the amount of technology and innovation that we're seeing, well, throughout the day here. It's going to be a fascinating bunch of discussions. Thank you all from everybody who's joining. I see we have folks from Germany, from Italy, from Argentina. We have over 3,000 people registered for today. So obviously, as we go through, and a lot of folks will be watching the recording later, again, thank you to everybody. Thank you to IIoT World for hosting this. They're sponsoring this session. And it's my privilege to be opening the first session of the day on a topic that's very close to my heart, digital twins enabling the energy transition faster and more sustainable. So before we kick off, just some quick housekeeping. On the tool that we're using, again, you will see we have Q&A, you have some chat functionality. If you have any question as we go through the day, please do use the Q&A functionality. I will be watching that as we go through, and we'll be picking questions because we want to try and keep it as interactive as possible. Now, obviously, we have, pretty much a who's who of the digital twin technology world joining us on this panel. I'll quickly do introductions in a second. We're delighted to have these folks. If you go to the IIoT World Energy Day webpage, you will find everybody's biography there and a link to their LinkedIn account. So if you want to reach out and connect, please do follow, connect. And if you have any questions as we go through and you want to follow up later, again, chase the folks down on LinkedIn. We'll also be posting out kind of summaries and whatever towards the end of the week. So with that, over the course of the next 55 minutes or so, we want to get into digital twins, enabling the energy transition faster and more sustainable. Now, I'm delighted to be joined by 4 colleagues from the industry. And as I say, it really is a who's who of digital twin technology and the energy transition. I'm delighted to be joined by Peter Terwilliger, the Director of Worldwide Process Consultants at Dassault Systems. We have Brad Johnson, the Senior Product Portfolio Manager for Energy at Bentley. We have Scott Hamilton, the Vertical Lead for Energy in the Americas at Unity. And we have Guy Guritz, the Regional Energy Industry Sales Leader here in Europe for NVIDIA. So we were chatting earlier with the folks backstage, having the leaders in the industry from Unity, from Dassault, from Bentley, from NVIDIA on the same call to share their thoughts and answer your questions. This is pretty unique. Now, in the build-up for this session, we had a couple of calls and a lot of emails back to back. Our biggest challenge is that we have 55 minutes. We could probably speak for the next couple of days on this topic. But personally, myself, my name is Kevin O'Donovan. I'm delighted to be supporting IIoT World. I'm a technology evangelist. I spend my time looking at new technologies and how we can use those as the energy transition takes place. Now, I'm an optimist, but I'm also a realist, and not all the technology, technology for technology's sake. So when we were, when we were chatting prior to this session, we were looking at, and I passionately believe that as we go forward, the current state of digital twin technologies and what's coming down the line, we are at a unique place in the industry. We have to accelerate how we design, build, and construct and get working the new infrastructure to enable the energy transition. I believe digital twin technologies have a huge part to play in that. The ability with the digital twins that we have today and what's coming to simulate everything, the what if scenario planning. We've never had that level of capabilities. And we'll hear about the democratization of these technologies that we have today. Once you start designing, you start building, you start the infrastructure starts running. Again, with digital twin technology, the ability to optimize, do predictive maintenance, to do scenario planning on what if we go faster or slow down, what are the implications? Again, I think we've never had this capability. And the ability for us to be able to collaborate and knowledge share right across industries, companies. To me, where we're at today is that it's about breaking down the silos, either inside a company or across companies. Now, many of you will probably say, but Kev, digital twins aren't new. We've had digital representations of stuff for decades. We've have. But my point being is that most energy companies that I work with today, they have multiple digital twins. But the feature being is they're kind of siloed. And where we're headed is pulling all of these together into one digital twin, one version of the truth where everything happens in almost real time. So digital twins are not new, but this is different. Now, digital twins are, as we head down into the industrial metaverse, it's digitalization. And digitalization is hard. And we all hear the stories of, well, we had a lot of digitalization projects and they didn't work out. So that's not gone away. Neither has cybersecurity. So this stuff is hard. And some would look at this as digitalization on steroids. Some folks would also look at this and say, Kev, this is fine, but this is all for the big guys. The guys with loads of IT folks and loads of engineers, and they have all these capabilities. So I would challenge that, because what's happening is we're democratizing a lot of these technologies. And whether you're a startup or an SME, you now have access to these kind of capabilities through the cloud. And we'll hear more about that as we go through from all the companies. So again, it's not just for the big guys. And it's not that it's so expensive. I disagree. Again, it's all about starting on that path towards, accelerating the energy transition and how we can get there. So that's my point of view on that. So what I would like to do now is we're going to go around the table and get about a 2-minute opening statement from each of our distinguished panelists in terms of where they see all this headed. Maybe they agree with me, maybe they think I'm mad, whatever. We'll have a good discussion. So with that, Peter, what's your point of view on all this?
Well, thank you, Kevin. And it's a real honor to address this august body of people. I am Peter Twilliger, and I am the Technical Sales Director for Cloud Sales at Dassault Systems. And I want to talk about something that Kevin just mentioned. He said something about this is not new, but it's different, right? It's a seemingly contradiction. It's an interesting point and something that I'd like to come back to later. We live in a world that's facing unprecedented challenges: climate change, population growth, environment, energy transition, sustainability, and then all the stuff that we've been dealing with since we turned the lights on, however many thousands of years ago, right? Wars, all that kind of good stuff. In our discussion today, we're going to get excited. We're going to talk about some wide-ranging challenges, quality of life issues. We're going to talk about continents, countries, all that kind of stuff. But as we talk, I really want you all to think about how you can make this transition actionable for yourselves, right? It comes down to a couple of key things. We need to understand what we have, modeling our existing infrastructure, know what it is, know what it does, know its limitations. And we're going to need to grab and collate and gather and analyze reams of existing data from all over the place, all different systems, all different challenges, everything else, right? Collaborate with our stakeholders, a big deal, to understand who we're serving. We're going to need to be talking to citizens, governments, customers, local municipalities, everybody, stakeholders. And then that's all going to go into the pot, and we're going to need to develop a strategy that's going to involve designing, simulating, redesigning, collaborating, optimizing, right? Stuff we've been doing, but different. And then when that's all done, obviously we need to execute on that. You're going to hear today that virtual twins are the serious tool that's going to help us address these serious challenges in front of us. They're going to enable our energy transition. It's enterprise level software, right? Integrated end-to-end systems that can go from concept to design to collaboration, all the way to fabrication and installation. It's software as a service, as Kevin said. SMEs, small people, small companies, just single individuals. It's available to anyone. Very low barriers to entry. You don't need databases. You don't need IT departments. You don't need funny looking people with hats with clovers and stars on them. It's available to everyone. It's on the internet. It's cost effective. With that cloud comes great data security, right? That goes without saying. It's accessible from anywhere. I haven't tried to access it from my toaster, but I'll probably get around to it at some point. So the point is how to make this actionable, big or small. How do you play your part? How do you get your hands on the tools that you need to do this? How do you include everybody? How do you collaborate? We believe that's virtual twin on the cloud, and look forward to speaking with the group and everyone today. Thank you.
Thanks, Peter. Guy, what's
Yes.
your thoughts on this?
Yeah. So first of all, I mean, the company I work for, NVIDIA, we're basically about high performance computing, visualization, and AI. So applied to the digital twin, as you rightly said, there's nothing new, but certain things are new. One of those things is being able to do photorealistic rendering in real time, being able to run simulations at speed, and being able to incorporate AI connections to the real world. So all of this digital twin stuff, it's now possible to model. I mean, everything that can be built starts off in the virtual world. So, and that includes the subsurface. I'll even include subsurface formations, which really start off in the minds of men. They turn into models. Now we're applying digital twins to a very wide series of problems to do with the energy transition, which have to do with how do you generate lower carbon energy, how do you transmit it, how do you distribute it, all of which we have the tools to embark on this journey. And I would say it is a journey. I certainly don't know the answers, how to decarbonize to the extent required. There are many possibilities, renewables, nuclear, CCS. All of these will have to be modeled, tried out, simulated before, of course, they go and take the step of actually implementing these things. Some of the things are in process already. Many of the things are still quite contradictory at different points of view about renewables, about hydrogen. But all of the things that we are doing at NVIDIA is really to enable this process. We are an accelerated computing platform that can allow these kind of tools to be used. And we are not competing against an army of people who are either established or new players. We're just providing the AI platform to do all of this. And that can include, SMEs, it can include startups, it can include established companies, whether they're in the cloud or on their own premises. But all these things are possible. What we face and what the industry faces is this trilemma of security of supply, low cost, and of course CO2 reductions. And this is something I don't think anyone has the answer to. We will have to just work through the various options over time. And this is really the alignment that we want to do as NVIDIA.
No, thanks, Guy. And again, we come back to it. To me, it's about the ability to simulate the what ifs, right? We've never had this capability before, so I think this is where it changes the game. But Brad, from Bentley's point of view,
yeah,
where do you guys see this playing out?
Well, I think going back to your opening remarks, that digital twins in some concept have been around for a very long time. We look at the early days of digitizing a 2D drawing, and then eventually we got spatial with various spatial systems, whether it's GIS or just simple spatial databases. And now we talk about, then we jumped into 3D, and now we're getting into 4D. What does that mean? Well, adding depth to this data. And I mean, that's very exciting. And we've seen other industries outside of energy embrace some of this faster. Manufacturing is an example, plant construction. And now we see energy really having to embrace this because, as you said, the rate of change has never been so great. Well, unfortunately, the rate of producing professionals for industry has not kept up with this rate of change as well. So we have to leverage these new emerging usage patterns for digital twins to enable us to keep up with the work that the quality of life of our communities depend on. And as more quality of life attributes depend on reliable electric delivery, we have to get creative to it. So, at Bentley, we obviously have tools that leverage and can populate digital twins. One of the things that I look after between where energy is produced and where it's consumed at a meter I'm interested in these practical applications, and we see new practical applications emerging every day from our user community. We highlight a lot of those in the fall at our Year in Innovation Awards that we do. I'm really excited to see practicality approaching this. And I think that's an important message for the attendees to understand, is this isn't just some idea that some creative thinkers have come up with, but this really is in reach. And for the non-technical attendees who are in decision-making positions, this is the time to really step up and provide leadership and get these types of tools in the hands of your people so that they can complete the work they need to do quickly, reliably. And it's on us as solution providers to create those approachable and achievable or adoptable solutions to get you into that better place.
No, thanks, Brad. And your comment on, well, where do we get all the skills, and what skills do we need, and whatever, that we'll certainly come back on that one. And Scott, from your perspective, where's all this headed?
Yeah, it's interesting. You guys have all had some great points, and I pretty much agree with all of it. From a Unity perspective, Unity Technologies, right? We're a gaming engine. We're actually the world's leading platform for real-time 3D content. It's not about a solution or a single twin. It's about building a twin infrastructure that can manage this content that's being created in a new way, right? A 3D asset. How do we actually make sure that the right people have that? And we talked, someone mentioned security a little bit, but you're going to have to get it into a place in order to manage it. And then someone's going to ask for it, right? Whether it's a training person or a safety person or a maintenance person. And that's going to dictate what data is integrated into that 3D asset. And so, we look at it as an ecosystem of partners. And if the 3D asset is held in our environment for whatever reason, then we would need to pull from a Bentley, for example, or a Dassault to get quality data into that 3D asset. Because when you think about digital twin and the process you go through to realize your business goals, it's a maturity model. And the further along that maturity model you get, you're deepening your relationship with data. And so it's an IoT system, or it's a SAP system, right? So you get a variety of live systems that are out there that need to integrate into the digital twin in order to work.
Thanks, Scott. And we come back to that because I think one of the key things and the reason we have the 4 companies here represented is that, we always spoke for you. I was in Compaq and Intel and whatever. Oh, well, we all can't do it alone. And in today's world, and you see what's going on, I honestly believe, you can't do it on your own. But if you look at the partnerships you guys have and how you get that data back and you break down the silos, you get data transparency across multiple systems. Now, I grew up in the old ERP world where you'd have to have an enterprise service bus connecting all this stuff, right? That day is gone as well. So I think we're at a fascinating time. Now, just quickly looking online, we have 352 people live. So thank you all for joining. Lots of folks in the US, we have South Africa, Switzerland, Germany, Houston, the UK, everywhere. We have one question in the QA already, two. First one around the truth of data. We'll come back to that one. But let's dive into a couple of the topics and whatever. I kind of started out and said, look, we need better pace of change for the energy transition. And I honestly believe that by doing everything in a digital twin, whatever platform, designing it, building it, training staff before you build anything, helping the regulators and people who are wondering, well, what will this look like? Whether it's a transmission line, a hydrogen plant. Guy, you mentioned subsurface. If we want to start doing carbon capture, we use the same kind of technology that we use in oil and gas to model the reservoir, blah, blah, blah. So I honestly believe that digital twins, that technology done well, will help us accelerate how fast we get things done. So if I may, Guy, I'll come to you. Do you guys see that people are looking at this as a way of expediting the process to get stuff built?
Yeah, I think the problem is really two things: is how you do things today and how that may have to change in the future to accommodate, CO2 emissions reduction, CCS, and so on. For example, a lot of the reservoir simulation modeling and simulation that goes on now is highly applicable to CCS. But what it needs is a combination of what is essentially modeling the whole engineering part of it, the surface facility, the pipelines, the injection wells, and then to go on into what is really a multi-scale problem, which is what happens to the CO2 when it goes into the reservoir. How does it plume? How does the plume expand? Does it reach a certain safe pressure limit? What's the gas saturation? All these things, God knows how they're going to pay for it. But at the moment, the first thing to do is to model it, how it can be done. And from there to see how you're going to actually do it economically, as well as, well, dealing with all the other problems, which is, of course, regulatory. It has to do with how we find the suitable reservoirs in the first place, how these are interconnected, how they communicate with each other. And all of this requires a lot of what's essentially a digital twin of the subsurface, together with what is all of the mechanical process engineering parts that go into that solution. And that has to look realistic, and it has to be connected to the real thing if it exists. It will have to when it does exist, but even before it exists, it has to be realistic. It can't just be a sort of crude model, as that won't really show enough information. All of the detail has to be shown. It has to be engineering detail, not just a representation. Things like chemical effects, corrosion have to be shown. All of that has to match with real sort of video of the actual asset, wherever it is. So all of these are tools which need to be put together and, justified. And I think that's the last and most important thing. There's many things you can do. Why would you do it? What would be the payoff? I mean, we are essentially in an industry which is it's certainly oil and gas industry is capital intensive, commodity traded industry. The other end of the spectrum, of course, utilities. But for any of these things, the investment which is made, why should we do it, and how will it pay off? Is it going to be because of government policies, government grants? Is it going to be because you can actually turn that into a profitable line of business? We don't know those things. Mm-hmm. But the first thing is what you said earlier, is it has to be modeled, how you do it today, what the possibilities are, what the scenarios are, what they look like. And in the final analysis, what does it look like from a cost point of view?
No, good points. And if I may, I'll come to Scott, then Brad, and on to Peter. But I think one of the things I'm very bullish on this technology, right? But the thing that I would say, and Guy, you mentioned it there, and Scott, this is not just animation of a digital twin. Right. It is about physics, modeling, simulation, and whether that's the corrosiveness of a type of gas, the mix of gas, the liquids, whatever. And people would say, and Unity, it's a game engine. But you guys have physics engines for all sorts of stuff, and then you combine that with some industry-specific stuff. To me, that's how we get there. So, Scott, I'll throw it over to you.
Yeah, no, that's a great point, and that goes back to that whole idea of an ecosystem of partners, right? So you talk about one can't do it all. We can democratize some things that we can't do on our own. Yes, we have a certain level of physics that we can go after, but when you want to get really into the detail, you'd want to use something like maybe ANSYS. Yes, we can do quite a bit of AI work, but we think NVIDIA probably is going to be someone who participates and contributes to that process for us as well. And so we believe that is a part of that. One of the things that we're helping, right, is this unlocking of the data. Getting these 3D assets into a place where you can manage them, that ingestion process is hard. And so we're bringing that along as well with that. That's kind of, the idea of, I want to take a 6 gig model, right, and pull it into an engine and play with it. It's not an easy process. So how do you manage that in a way that is effective and lightweight, and considering WebGL as well in a lot of these processes? And then the streaming part of it is a big part of that. So when you talk about the front end of the workflow and the back end of the workflow, getting it in and then pushing it out, those are big considerations. All of this stuff in the middle can be the compilation of a variety of partners and players that come in to make it real. But you're right, photorealistic is a big part of that. And the unlocking of the silos in real time is one of the most effective ways of managing that.
Thanks, Scott. Just before I come to Brad, folks, I see the questions are piling in. Also, for everyone online, we've got 375 folks. You can see all the you should be able to see the questions. You can upvote them, so you can make my job easier if we see who gets the most votes. Otherwise, we could be here until 8 o'clock this evening. Brad, I've had the opportunity to see some of the capabilities you guys have in iTwin and whatever, the ability to do metal fatigue, blah blah blah, right? So again, the simulation piece. I'm not sure everyone is aware that this stuff exists, and now it's bringing in the different capabilities from industry players, game engines, whatever, right? Or am I smoking something?
No, I don't think you are. Well, maybe. No, I'm just kidding. I think probably what's really exciting is the fact that that the data that drives a lot of this is so much more accessible than it was 10 years ago or 13 years ago, when in North America we were looking after FERC or FAC 003 and 008, the vegetation clearance and transmission, and how much per linear mile it costs to acquire high quality LiDAR and photogrammetry along with it. It's very cost prohibitive. Where today we have users showing us how they're using very affordable remote sensing equipment that's handheld or put in a tripod, and creating reality meshes of substations like that. I mean, somebody might say it's probably gonna look like Doom if I can make a gaming reference, but no, it looks much more like a modern game, like you would see in the sports games that are out today, where you're like, is this a video or is this reality mesh? And so, but that data is only, that accessible data is only valuable if it's easy to use and easy to get into the system. So like for us, we take a very open approach. We have tools that make it easy to pull this data in, whether it's remote sensing or IoT data from sensors that are collecting in real or near real time. So that's the exciting part for me, is that all of these ideas that we had thought about 10 years ago are finally accessible. They're affordable. And going back to what we started out, the rate of change demands that infrastructure owners and those who serve them embrace it, because really we don't have much of a choice in the matter. And for us, in what I'm in another part of the country here to talk to a major investor-owned utility today about how do we bring this data in to make them more efficient. That doesn't mean reducing headcount. That doesn't mean cost cutting. What it means is, how do they get the amount of work that needs to be done with the reality that it's not slowing down and there's not these new people coming in. So we're excited. It's getting accessible. It's becoming practical, and our investments in making things very open, open APIs, open toolkits, is paying off, and we see that in how our users communicate back to us.
No. Now, I'm going to circle back around, but Peter, I'll come to you in a second. Peter, excuse me. And I'm going to come back about the data. There's a lot of questions here. There's obviously privacy. There's also, how do I know the truth of the data? How do I tie back the simulation to what happened in the real world? So we come back on that. But Peter, Brad just mentioned about the accessibility. And again, I believe that we're at a stage in the industry that this isn't all for the big boys, startups, whatever, on all platforms. And Peter, you mentioned as well about like the software as a service and cloud and data interoperability. So do you see that tying in so we can mix and match, if you like?
We do. We definitely do. We think that's probably one of the most important things. Scott mentioned the ability to visualize in 3D. Brad was talking about the data and getting the data in there. Those are all tools that are incredibly important, but we also need participation and collaboration with everybody. Whether, it's a recurring theme in our discussion here has been that we're not in this alone, right? We're in this together. There are big people who have all kinds of technology tools. There are skilled people who can use amazing 3D modeling tools that can model anything. And then there's people like me that can look on screens and sometimes with my whiteout or crayon mark up something that I see on my screen and go from there, right? We believe at Dassault Systems that all these people have something to say and something to participate in. And the cloud, it's software as a service. It's accessible to everyone. And we put tools, all of us have tools in there that give us the ability to access that data, right? To make that data accessible. The people who make it use tools that have the skills, then require the skills to be able to do what they need to do. Simulation engineers, modeling engineers, all kinds of amazing engineers. And then there's the stakeholders like me that just need to provide some markups. And then most importantly, we don't get lost, that input doesn't get lost. The public needs to participate, the governments, as we talked about before. We're not doing this in a vacuum. This is something that we're in this all together. And that's that collaboration piece that software as a service offers us that's different. And that's that concept again that Kevin was talking about, same but different.
Alrighty. Folks, for the whatever 370 people online, I made a slight mistake in terms of the questions. I just published the questions. I didn't realize this tool was so advanced. So I was seeing the questions and no one was voting because I hadn't published them. So my apology, my bad. So they're now published and the things are popping up. So let me take this one. Gareth posted this question, Gareth Newman, and he was talking about, and I'm paraphrasing here, but it's a pretty philosophical question in terms of, well, how do you define the truth? I mentioned the one version of the truth. Now, I'll kind of give my perspective here. I'm not going into the fake news type of discussions, but if I may, I have worked with energy companies long enough that you go, we have data, we've deployed lots of IoT stuff, smart meter, whatever, and they need to trust the data. And then they have to, there'll always be some outliers and they have to sanitize the data. And I know all of you folks in discussions with you, you're doing a lot of that to kind of clean up the data. And I'll tie that in with the question from, excuse me, I'm just searching through here. It was around, how do you then map that back to, if you have a physics model, how do you know that your simulation actually was correct, or how do you retrofit that? So I'll throw that open to whatever. So if anybody, just raise your hand and I'll come to you. Trusting the data and tying it back to the real world. Brad.
Yeah, I think the clarity around attribution and understanding what the data represents is the most important. So the timeliness of the data, so that decisions can be made based on how recently the data was collected, classified, processed, et cetera. The level of accuracy that was involved in acquiring the data. If you're talking about IoT systems, what's the polling interval? How real time or what snapshot in time am I looking at? I think if we expect that every bit of data that's in our systems is 100% real time correct, we're letting perfect be the enemy of good. What I think is important is to expose how accurate or apply a gradient to say how reliable is that data given the type of decision I'm trying to make at that time. If I'm trying to redesign a substation and I know there haven't been any work orders there for 2 years, that LiDAR and photogrammetry process 6 months ago, I could probably rely on that pretty well. I might double check with SCADA and with system operations, make sure they haven't changed anything, but that's going to be really great. If it's who's attached to my pole to provide broadband access and it hasn't been surveyed for 5 years, I should be very suspect of that. And it might be worth sending a crew out to go take a look. So I think it's not so much a question of the level of accuracy or the truth of it. I think it's understanding the context of the data and using the appropriate judgment. It's the human part of automation that is very difficult to automate. Using judgment to make those calls.
And I would say to add on to that, Brad, that with that being said, there is the possibility of space and time to be a little bit more accurate when you do integrations of like GIS systems, for example, to get to that point. That idea of how reliable is the data and how recent has it been done is that whole concept of how do you keep your twin evergreen as well. And that idea of, the AI is going to be a big part of this, right? Because as the drones come into play, I see one in your background there, Kevin. You got one over your shoulder. But that's going to be a big part of the process, right? You're going to have regularly scheduled drone runs to make sure that you're keeping up your data on a regular basis. And then how reliable is that data? Because drones are only so smart today, so they can only capture the top of it, right? You can't necessarily get underneath for the inspection. As a person looks at an inspection, do you artificially create the bottom layer that you didn't cover because we kind of know what it should look like? But no, because from an inspection perspective, it has to be actually precise. So they'd rather not have that data than have false data in that scenario. So it's knowing the limitations of your data and knowing what you have. And I think you go back to that idea of a maturity model. We're going to see the evolution of this continue to grow every single day, right? It'll be a continuous improvement within this space. We're in the digital twin's been around for 2001, I think was the first time it was thrown out there or what have you. But we're just now getting to the place where the tech and the hardware is catching up to a point where we can actually use it effectively. Mm-hmm. And so, that's really kind of where we're at. Sorry, Guy, go ahead.
No, just to say there's more than one way to look at the problem anyway, and that there should be more than one way. You could take a data-driven approach. There is a physics modeling approach, and that was the more traditional way to do simulation. If the problem is hard to model, then a data-driven approach is best. I mean, the third thing is a human pair of eyes. I mean, none of this should really be done without certainly some scrutiny from a trained human being. Yep. We can use PIMs, physics-informed neural nets. In many cases, we have to generate a lot of synthetic data in order to train the model to do accurate simulations. But I think with all of these things, you can't just take assume one approach is true. It has to be validated from 2 or 3 different angles and different ways of viewing the data. So, I mean, going back to this thing about the truth of the data and the data quality, I think this is going to be extremely important for the future of things like generative AI, particularly. But within an IoT basis, it's really a question of how did we do things before? What kind of physics-based approaches did we take? How much data do we have available to use PINs? And how can we, if necessary, generate synthetic data, which will allow us to have a very accurate simulation which will match the real-time data coming in from the sensors.
And as a synthetic data matures, Guy, to that point, you'll remove bias as well.
Yeah.
Because you...
Yeah. I think there's one more point that we also need to mention, right? Back in the day, there was an old adage that said the data is the data is the data, right? What does that really mean though? So when I was a young engineer back in the day, we used to take drawings, we marked them up with red pencils for stuff we wanted to remove and put green pencils, and we rolled that up and sent it off in Federal Express, and the operations manager of my local nuclear plant had piles of my old drawings on top of his desk. He never knew which one to look at, right? So when we think about the data being the data is when you look at it in a 3D perspective, it looks like, or a 3D set of lens, it looks like your 3D model. When you look at it from a bill of materials perspective, it looks like your bill of materials for purchasing. When you look at it in, I just need some drawings for regulatory approval, you look at it through a 2D lens and it's the drawing. It's the data is the data. You're always on the same page. That's incredibly important. And to bring that accessibility to everyone, all the stakeholders, is incredibly important.
No, good points. Now, the questions are flying in. I cannot publish them as fast as they are appearing, so I'm going to group a couple of them together here. We have Walter Heffel asking about the reliability of data. I think and again, we could spend hours discussing this and getting into the gory details. And my own personal perspective of this is that if you look at something like NERC CIP in North America, when you're talking cybersecurity, it's not that you have to protect everything the same way. It depends on the risk and the data and the usage model, blah, blah, blah. Peter, you said data is the data. You have different types of data. And Brad, I think you mentioned some of it. You might want real time, especially if I'm doing transmission power lines, that millisecond, right? But other stuff may not, I can have a greater scope of, it's kind of okay. And I think that depends on the use case and whatever. And obviously everybody would like something, and everything would be real time, but even with smart meters today, right? Some are 5 minutes, some are 15 minutes, some are once a week. So not guaranteeing the reliability of data does come down to, well, what's the data? What are you using it for? And how mission critical and time sensitive is it? One I'll throw out here quickly to all of you. And this is coming from Binod Kirola, and I apologize, I've probably mispronounced that badly. Data privacy. Who owns the data? Anybody want to jump at that one?
Well, I think I'll start. Years ago, when companies would ask for a solution to a problem, the solution was built in a way that managed the data in a certain way that was acceptable at the time. And today, people are asking for problems to be solved with the data being handled in a different way. And what I mean by that is they want to own and access their data themselves. They want to retain ownership of that data. They want to be able to put it wherever they want. They want to bring their own storage. They want to make sure that the identity is done a certain way. And if we as a collective group, right, or people that are entering this space of the new technology are not meeting those customers in that place where they want to be, which is managing their own data, then we're going to find ourselves at the brunt of some hostility. And so I think when you say who owns the data, when you're talking about a super major or a large power utility company, they want to continue to own their data. So they're not going to give all of their data to Unity in this example, right? And have us house the data and hold it hostage and make them beg, borrow, and steal to get back. They're going to want to say, we want to use your tools as a service-based architecture, right? An API model that's modular, where we can pick and choose things that we want to help with the data flow as people are using it for whatever use case that they're going after. And I think that's something that we need to look at as a software industry and meet the customer where they are, because things have changed in how they're asking for the data to be used. We're using data in a different way than we have before.
Yeah. I totally agree with that standpoint, Scott. It's amazing to see the changes in data. I do think there's one caveat that maybe we're trying to address that's a little bit different from what you're doing. We're trying to put all that data in the same place. And that's going to take some pretty heavy duty databases, some pretty heavy duty IT stuff. So we believe that belongs on the cloud. We believe that we can manipulate that data only to the extent of putting it in at the right place, make sure that it's backed up, that it's in the databases to make all the tools work properly. But at the end of the day, it's your data. You own that data. You configure that data and you can get that data out of there. But we think it's very important to have that data in one place so that everybody's on the same page. And so what you said, with an addition of saying, hey, let's put it all in the same place where everyone can get to it and look at it using the tools that they need.
And I think it's important to remember that given that utilities are comprised of people, just like the five of us are on this, that our perceptions are driven different ways. And I think the B2C model of how data is handled in the cloud, when we think about Apple iCloud or OneDrive or Dropbox, that's a totally different. When we have to be careful when we're communicating to help people understand when we say cloud, what it really means.
That's a good point.
In a utility perspective, a cloud doesn't mean we throw it up, the same place that somebody's hosting their website, they're selling their stuff on Etsy. It means putting it in a piece of infrastructure where it's safeguarded. And thankfully for us in the energy world, the defense industry went first, which is very interesting if you think about it. And a lot of the lessons that they learned in protecting really the most secure data, we're leveraging that same approach to security. From an ownership perspective, I think there's a dichotomy almost that's emerging. On the one hand, utilities, obviously, there's a lot of intrinsic value in the data that they produce and hold and have. It's an asset. On the other hand, they want automation to drive efficiency that depends on being primed with data. So you have, on the one hand, it's my data, don't look at it. On the other hand is, I want to glean all kinds of insights from this data. That requires training. So there's almost this emergence of a need of cooperation among utilities globally to maybe obfuscate a little bit of the sensitive part of their data, but really contributing to pattern matching and pattern building. Trends. So that vendors like us can provide the type of automation they're looking for, not fully human-assisted automation. So that it's this conversation that has to happen. We're here to support it, but it really has to be an agreement between utilities, really, to say, well, what are we willing to share with each other to drive efficiency? In the U.S., it's Edison Electric Institute is a venue where that kind of knowledge has been shared in the past. You kind of need the same thing for data, I think.
So, folks, we've about 12 minutes left, and I want to get on to skills. And obviously, we'll wrap up with, where would you send people to, or what are your parting statements on how people approach this? And we're scratching over the surface here. And cybersecurity, data interoperability, whatever, right? We're not going to get there. And as I say, we could have a whole week conference on this and we still wouldn't cover all the topics. But I'm going to jump, I'm going to kind of reset a little. We're 45 minutes into this. And there's 3 or 4 questions in here. David Syme and a few others I'm going through here. And they're kind of going, okay, how do you define a digital twin? Everyone's got a different definition. And now I know all of you have definitions, and this is one of the features. So how do you answer, and I'll come, Peter, I'll come to you first. How do you answer someone when they say, you know, yeah, digital twins are not new. Yeah, all have different versions. How am I going to get them all to work together? And fine, I was going to say I'm not putting you on the spot. I am putting you on the spot. But these are the conversations you guys have with your customers every day, right?
Yeah.
So
Absolutely.
Peter.
Absolutely. Thank you, Kevin. A virtual twin, I mean, we've had all kinds of questions about virtual twin. For some people, virtual twins are just the plain 3D model. It's an amazing thing to see a model of whatever it is they're working on the screen, right? And they're like, wow, that's really cool. And maybe I need to go ahead and, think about simulating how that thing is going to work. But right now, I'm just excited to see it. Other people, it's, I've got a connection directly to the live meter, the power meter, whatever it is, and that is providing constant feedback. The neat thing is there's 4 things that we see in a virtual twin. Is collaboration, right? Everybody has a stake, everybody has a role. I've mentioned that several times now. Modeling's the starting point. How do we get all that information in there? How do we have the tools that pick up on data in one format from the other? And how do we put that together? And then what do we do with all that? How do we use it? That's that optimization part, right? That's the payoff part. I can optimize my virtual twin on the machine without building anything. That is pretty cool and pretty sustainable as we talk about transitioning to green energy, right? I've got the ability to optimize that. And then ultimately, if I go the next step and start hooking up with sensors and connecting that all together, now I can monitor performance. I can further optimize. I can make those changes. It's the same but different. It's a much further along type of solution than what we've done in the past. Did I answer your question, Kevin?
No, and there is no right or wrong answer, but I find it fascinating, and it is perfectly legitimate for a lot of folks here to go, well, what do you mean by a digital twin? Because we have been using the same term, it's like industrial Internet of Things, right? It means many different things to different people. Guy, if I may, I'll come to you. When in NVIDIA, when someone says, well, what do you mean by a digital twin? How do you guys answer that?
Yeah, well, it depends if the real thing exists or not, I would say, because a lot of the time the virtual version is first. One of the things we're doing a lot of is robotics, and you can't build a physical robot and then train it. It's thoroughly dangerous. So you create a virtual robot, and then you create hundreds more, and then you train them. And at a certain point, you're going to finish up with a mature training system. You can put it in a physical robot, and that's just an example. So a lot of these things, they start off in the virtual world, and for a long time they will stay there. The other thing is that we have a tool. It's not our tool, actually. It's a Pixar universal scene descriptor that we use to bring a lot of different applications, models from different applications into the same model space. And in that space, multiple users can actually see the same thing. So they can actually collaborate and work on the model, whatever it is. But I mean, pretty much anything can be simulated. You can ask a director of R&D if he wants to spend money on a new laboratory, for example, chemical laboratory, or if he's just going to use supercomputing to simulate all that, because you can. So it's a very, very general term. I think it's come from the fact that, SCADA systems and so on, you have a physical asset, you want to have a digital version of it. Often it's retrofitted. But these days, I mean, the problem used to be that you couldn't really model it very easily. Now with NERFs, with this neural radiance fields, you can model very complex piping very, very quickly. And turn that into meshes, and that will be your model. And then you can do all kinds of simulations, whether it's internal to the piping or it might be airflows around the piping. All these things can be done. So a digital twin is basically a version of the real thing, which eventually probably will exist. But for a long time, it will start off as in CAD software. You're probably going to augment that with some stuff on site if it's already built. But the point is, you should be able to simulate how that thing is supposed to work or is working, And that should be then directly comparable to the data you're receiving from the sensors attached to it, because that's a really big value in terms of being able to do things like predictive maintenance, any kind of anomaly detection. So it's a huge field, and it can be mechanical, it can be geologic, it can be chemical, very, very wide field. So I guess that's not much of an answer, but it's really just to define the scope of what these things are. 3D modeling, yes, simulation, AI, and collaboration, as you said earlier.
Well, I'll come to Brad now in a second, and then Scott. But just again, a quick comment from myself was that the art of the possible when it comes to a digital twin, and whether it's design or implementation and joining them all together or whatever, we've never had the capabilities that we have and the accessibility for this stuff. But it will come back to, you're not just doing it for the sake of it. Yet, what's the problem you're trying to fix? Yeah. And if you're trying to fix the problem of an integrated carbon capture system in 20 years, fine, you can go off and do that. But maybe it's, I just want to figure out where to put electric chargers for electric vehicles next week. So it depends on it has to come back to a business case and what are you trying to fix? Brad?
Yeah, I mean, I go back to what I think I said at the beginning, is practicality. We look at utilities like Essential Energy in New South Wales, Australia, and their approach to what digital twins means that they've reduced the amount of driving they do to visit remote substations by 80%. And that's a huge impact, not just on operational efficiency, but also risk reduction. Fewer miles driven by colleagues means less risk exposure being in the field, less carbon emission from transportation. It also means faster time to service from when something needs to be done to when it can be done. And so, Bentley being an infrastructure company, squarely focused on infrastructure, our iTwin, which is our interpretation of what digital twins are, really embraces a lot of different things, whether it's real-time sensor data from IoT or remote sensing, or to what Guy was saying, what could be, that something doesn't exist in the physical world first, it exists in a digital twin world, in an iTwin world first, and then it becomes real. But then eventually there's this reflection between the real world and the virtual world, or this documentation of the world that's out there. One of the things I would say to those attending is, and I've seen this, people get vapor locked. They get locked up. Like, what is a digital twin? I can't possibly approach this until I have a textbook definition, and engineers haven't been one. We like things that are hard and concrete. Digital twin really is, look at each of our companies, how we're approaching this digital representation of the real world, whether it's contemplated or existing. And I would say to those attending is, come up with your own definition of what a digital twin will mean to your company by taking what any of your vendors or your partners or peers in the industry are doing and assemble your own story that makes sense for you. And if you approach it that way, I think you'll get more buy-in and adoption to happen to bring these tools on board. It's not going to be this ethereal thing that people have seen on billboards and sporting event commercials. It's going to be this thing that's real, tangible, and practical. I think that's what I would say when somebody asks me, well, what's a digital twin? I said, well, they don't like to hear it depends, I guess, is a bad answer. But giving them some crayons to color a picture with helps.
Scott, you mentioned as well, and I'm familiar with the Unity digital twin maturity model.
Yep. So I'll give you a quick 48-second response since we're running out of time, because I have a little story that I want to share about talent, if that's okay, because I know you danced around that a little bit. So the digital twin maturity model, right? So you think of digital twin as a virtual representation of a physical asset or a to-be physical asset. And then there are various stages that you go through. It's the virtual one where we were talking about, it's just a representation. It's the connected twin where you've got a data source tied into it. It's the predictive twin, when and should we do the maintenance. Prescriptive twin, these are things that we want to get involved where you're talking about real-time simulation and future scenarios about it. And then eventually it's an autonomous twin. Right, where automotive manufacturing companies are saying, come into our plant, configure your car, and in 4 hours, you'll have it assembled on the backside of where you're at. But some of that data isn't even, or some of that tech isn't even ready yet, right? So we're still looking at the future of those things. So that's kind of how we think about digital twin. It's Brad, it kind of does depend. It depends on where you are in your maturity around it. How much investment are you willing to make? How much ROI development have you done, right? There's a model around like, oh my gosh, you can start it at low cost, but it's a transformational technology. And at some point, it's going to be a program within your organization.
And I just want to add one thing, building what Scott just said. We went through this decades ago now with GIS. And even today,
True.
there's a maturity model for GIS.
Yep.
For some people, it's a simple math. And for other people, it contains rich sources of data that will populate and enrich the digital twin approach. So I think Scott's mentioning a maturity model. We've seen this before, so I think we kind of know how to write this version of the story around digital twins.
Or already, all right. We've about 2.5 minutes left, or
Okay.
Lucian and the team will give me a hook.
Can I share that little point on the talent?
Well, so what I'm going to do, I apologize. We have lots of questions. We didn't get to them. I'm going to go around. Each one of you will have 30 seconds for a closing statement. And I'll go Peter, Guy, Brad, Scott. Peter.
All right, 30 seconds. Let's say, for an instance, I'm a small utility. I've got a problem that all of a sudden, all the energy that's in a petroleum distribution system is now converting over into my electrical grid. In southern New England, where I live in the United States, the grid is horrible. It's old equipment, it's creaky, everything else. I've got to get started. Somebody asked a question. I apologize, I didn't catch their name. They said, how do I get started? What model do I use? What's the best one? The most important thing, the model, we got tons of models out there. We got tools. Everybody has the ability to do these things. The most important thing is we're not doing this in a vacuum. It's about collaboration. It's about enabling people to see the data in ways that they understand and can work on. Me and my crayon on my screen, and other people with the full-blown complicated tools that they need to use. That's what's important here, right? But get started. Make it actionable. Start figuring out, because those electric cars are coming off the assembly line. The utility grid, it's a regulated utility. Nobody wants three-phase power go down on their poles. So get started. And thank you. And it's been a real opportunity.
Thanks, Peter. Guy.
Yeah, I think for the energy transition, I personally believe that nuclear energy is going to be critical for that. And that means small modular reactors, molten salt reactors, and plasma fusion, all of which will be in digital form as digital twins long before they hit the regulators and get put into operation. But that's really the future for me.
Brad?
Yeah, I appreciate the conversation today. I think what I would say, I'll do a little shameless plug for myself. I sit in a role between our users and product development. Is the way that you would all can help drive this is be very clear, open, and transparent in your communications amongst each other, but also with those technology providers. The more we hear from you, the more we can react and put the right tech in front of you. And I love conversations like this, and Kevin, it's been great being a part of this. I really appreciate it.
Thanks. And Scott?
Well, you guys have all said it, so I'm going to tell you my story about talent. It's hard. Nobody knows whether they got it. There's a lot of people who've been doing it for years. So I'm at this event for young engineers, and this kid comes up to me, and he says, "Oh, Unity, I remember you from back in the day, yo." And I'm like, "Back in the day? What are you, a fruit fly?" And the best part is that he got the concept. He pulled his cane out. He's like, "Yeah." So I said, "Tell me more about this back in the day stuff." And he says, "Well, when I was 10 years old, I did my first Unity game. And when I was 12, I started coding in Unity." And I was like, "Oh my gosh, this guy's been coding for 8 to 10 years already." So the point of this story is that we are wondering where the talent is coming from. The talent is coming whether we're ready for it or not. We need to be able to adapt it. And if we can't do it, then we're not going to get this great talent. So don't fear the talent. The talent is coming.
Folks, I apologize. We're right up against the wire. We will be doing some blog posts and catching up on some of the questions. To my fellow distinguished panelists, thank you so much. Lucian, back to you. Thank you.